In 1917, the American military industry faced new challenges when Henry Ford received a commission from the United States War Department, one that was crucial for the country's entry into the war in Europe. The government formulated a requirement to create a light tank suitable for mass assembly line production, just like the Ford Model T automobile. Company engineers had to develop a machine that combined ease of manufacture, the reliability of automotive components, and the necessary combat potential. The task was viewed as feasible since the manufacturer had already demonstrated the ability to churn out machinery faster and cheaper than other enterprises. However, military vehicles required a specific approach. The benchmark was the French Renault FT-17 light tank, whose layout, with weaponry in a rotating turret, the engine in the rear, and the driver's compartment in the front, was considered the gold standard of modern tank design. Specialists from the United States studied the blueprints and technical descriptions of the French design in detail, analyzing its characteristics. This model served as a foundation for Ford's engineers to create their own design, which was intended to surpass the European prototype in manufacturability and cost reduction. The Design Bureau got to work, aiming to create not a direct copy, but a new American tank. The main condition was to maximize the use of automotive components and assemblies already being mass-produced at the company's factories. This method allowed them to significantly cut the cost of each unit and organize assembly line production to roll out hundreds of machines every month. The plan was to flood the European battlefields with vast amounts of equipment, using industrial might to create a numerical advantage. Early sketches of the new machine resembled the French Renault, but a decision was made to introduce significant changes to the design to simplify the process and lower costs. The most noticeable technical decision was the complete abandonment of the rotating turret, the manufacture of which required complex machining of parts and precise assembly of mechanisms. Instead, a 37mm gun and a machine gun were mounted directly in the front hull plate, giving the tank a structural resemblance to a self-propelled artillery unit. A fixed commander's cupola was provided for observing the terrain and assessing the situation, but firing at the flanks without turning the entire vehicle was impossible. The tank's power plant also featured a non-standard layout, which raised questions among military experts of the time. In the engine and transmission compartment, engineers installed two engines positioned in parallel. Each motor was paired with its own transmission and powered the track on one side. This layout, while justified by the ability to use stock automotive parts, created practical difficulties in synchronizing the power plants. To ensure straight-line movement, constant control of the engine revolutions was required, and if one failed, the machine could only spin in place. The suspension was based on proven technical solutions. 6 road wheels per side were connected into 2 bogies and suspended on semi-elliptical springs attached to a longitudinal beam, ensuring acceptable ride smoothness. Return rollers were placed above the road wheels to prevent track sagging. The geared drive sprocket was located at the rear, while an idler wheel of increased diameter protruded beyond the hull dimensions. The 2-man crew was stationed in the front part of the hull in a cramped space. The driver and the commander, who doubled as the gunner, sat side by side. The lack of a turret limited the field of fire, bringing the vehicle's characteristics closer to those of a tankette. In the spring of 1917, work began on a prototype for a 3-ton tank, developed as an American answer to European armor. Funds were allocated with the goal of having a finished machine by summer, hoping to organize shipments before the autumn mud set in. Work proceeded at an intense pace, aiming to combine automotive components with armor and weaponry requirements in a single design. The process was plagued by technical problems that demanded immediate fixes, all while time was running out. The main technical hurdle was synchronizing 2 independent power plants, each controlled by a separate transmission. In theory, this layout allowed the use of standard motors without major modifications. In practice, however, the driver had to operate 2 gear levers and 2 clutch pedals simultaneously while constantly monitoring the gauges. Even a slight difference in engine revolutions caused the tank to drift off course, making maneuvering extremely difficult. After testing, military representatives deemed the design unsatisfactory and demanded a rework. Designers spent several months refining the control system, searching for a balance between manufacturing efficiency and operational ease. They experimented with different ways to connect the two gearboxes, installed additional mechanical synchronizers, and adjusted gear ratios. Every change triggered a new cycle of testing, which only revealed further design flaws. As time passed without a finished prototype, the War Department grew concerned. The customers insisted on speeding things up, considering transferring the contract to other manufacturers offering light tanks based on foreign designs. Armor protection also became a subject of debate. The developer proposed minimizing armor thickness to reduce weight and use less powerful engines, which would have lowered production costs. Army representatives, on the other hand, demanded protection against machine gun fire at all combat ranges. A compromise was eventually reached. The frontal plates were increased to 16 millimeters and the side and rear plates to 13. This armor protected the crew from rifle bullets and shrapnel, but could be penetrated by large caliber armor-piercing rounds. The lack of a rotating turret created difficulties for weapon placement. The 37 millimeter gun was rigidly fixed in the front plate, offering limited aiming angles. To hit targets on the flank, the entire vehicle had to be turned, increasing its vulnerability while maneuvering. The machine gun mounted next to the cannon had an even more restricted field of fire. The ammunition was stored within the cramped confines of the hull. Shell stowage was designed so as not to interfere with the crew and to minimize risks if hit by enemy fire. The summer of 1917 was spent trying to eliminate the identified defects. Engineers reworked components, tested new materials for the tracks, and experimented with the suspension. Implementing changes required manufacturing new parts and running repeat tests. Production ran in 3 shifts to meet the deadlines, yet by autumn a finished prototype still hadn't been presented. This intensified the War Department's dissatisfaction, especially against the backdrop of competitors demonstrating designs based on licensed copies of French and British hardware. During the winter period, problems with operating the equipment at low temperatures came to light. Difficulties arose with starting the engines. The cooling system required modification, and the thickening of lubricants hampered the operation of the mechanisms. Special procedures for preparing the machine for cold weather startup were introduced, which complicated its operation. Testers noted that maintenance and preparation for combat use took more time compared to European models. The need to address these issues led to further delays. Only by mid-1918 did engineers manage to build the first fully equipped model, which received the official designation Ford 3-ton. The machine weighed about 3 tons, was a little over 4 meters long, and about 2 meters high. 2 gasoline engines with a combined output of 45 horsepower were supposed to provide the tank with a speed of up to 13 kilometers per hour on the highway and about 6 kilometers per hour cross-country. The range was approximately 50 kilometers, which was seen as sufficient for operations on a limited section of the front. Factory tests of the prototype began in June 1918 at the facility in Detroit. A military commission arrived to evaluate the results of the engineers' work. During the demonstration of the vehicle, officers noted the specific design, particularly the absence of a rotating turret. This technical solution sparked debate among the specialists. Some considered it a rational simplification, while others pointed out the tactical disadvantages of such a layout. The fixed observation cupola had a specific shape that evoked associations with submarine design elements. Starting the power plant was accompanied by technical difficulties. The engines did not run in sync, creating hull vibration. Starting to move revealed a problem with directional stability, and the vehicle drifted off course, requiring constant correction. To turn, the driver had to vary the engine speed, managing several levers simultaneously. Observers concluded that training drivers for such a transmission would take more time than for equipment with a single engine. Field tests uncovered a number of operational problems that hadn't shown up during bench testing. The tracks would periodically slip off on uneven ground and during maneuvering. The suspension on semi-elliptical springs provided a smooth ride, but when overcoming obstacles, it caused violent rocking of the hull, which made aimed fire difficult. The rear drive wheels got clogged with soil, causing slippage, and the large idler wheels, which extended beyond the vehicle's profile, were at risk of damage from impacts. Test firing of the 37mm gun confirmed the drawbacks of the rigid weapon mount. The gunner was forced to time the shot depending on the position of the hull relative to the target. Limited aiming angles made it impossible to hit objects located outside the frontal sector. Attacking targets from the flanks required turning the entire vehicle, which increased the time needed to complete the mission and unmask the position. The effectiveness of the machine gun was also limited by a narrow field of fire. Crew conditions were complicated by the high noise level from the engines and firing, and the ventilation system did not remove gunpowder gases effectively enough. In the final report, the Commission recorded the identified defects while also noting the positive aspects of the project. The use of automotive components simplified production and lowered costs. The armor protection and cross-country ability met the standards for light tanks of that period. The main advantage was considered to be the possibility of organizing mass production on existing manufacturing lines. Henry Ford told military representatives that once the issues were fixed, his plants could produce up to 100 tanks a month, ensuring the Army had the equipment it needed. July and August were spent tweaking the design to meet the military commission's demands. Engineers beefed up the track mounts, upgraded the engine control system, and improved ventilation in the fighting compartment. They reinforced the drive wheels with extra armor covers and installed more reliable sights. Implementing these changes meant more testing, which revealed minor glitches. At the same time, the factories were gearing up for mass production, buying equipment, training staff, and drawing up technical specs. The War Department approved a plan for an initial batch of 100 units scheduled to reach the troops by the end of the year. The company secured a government contract and funding guarantees. The production floors started churning out armor plates, assembling engines and transmissions, and making tank treads. Preparations to deliver the first mass-produced tank of their own design were moving full speed ahead. However, the reality on the front lines forced changes to the schedule. In September, news came from the Western Front that the situation had shifted. Allied forces had launched a counteroffensive, breaking through the German defenses. American expeditionary forces were joining the operations, using French Renault tanks. The effectiveness of armor in combat sped up the command's request for their own machines. By then, the company had built a few more pre-production models, bringing the total count to 5. The vehicles were undergoing intense testing on the proving grounds before their planned shipment to Europe. But in October, the strategic picture changed. Germany was losing ground, and its allies were dropping out of the conflict, signing armistices. The likelihood of a quick end to the war impacted operations at Ford's plants. Assembly rates dropped because there was a risk the project would become obsolete before the work was done. November 11, 1918 became the date that altered the future of the American tank program. At 11 a.m. Paris time, the armistice between the Entente and Germany went into effect, ending the 4-year military conflict. Word of the ceasefire reached the factories that same day. The news drew a mixed reaction from the staff. On one hand, the end of a massive conflict was a good thing. On the other, it dawned on them that their long work on the project had lost its practical purpose. The War Department slashed the order from 100 machines down to 15, and the question arose whether to continue the program at all. When the armistice was signed, the plant had 10 tanks in advanced stages of completion and 5 more waiting for weapons installation and final system tuning. Ford insisted on finishing at least 15 units, arguing they were needed to refine the technology and train troops on home-built machines. After some deliberation, the War Department agreed to accept the finished examples but refused any further purchases. So, the project for mass-producing a tank for the United States Army was capped at a batch of 15 vehicles, most of which weren't even fully equipped. In December, despite the weather, production dragged on at a slow pace. The staff didn't rush the assembly, knowing layoffs were likely once the contract was filled. Military inspectors also put off checking the equipment until spring, and the atmosphere at the plant was marked by a general drop in activity. Expectations for mass production didn't pan out, giving way to a realization of missed opportunities. Henry Ford visited the plant to motivate the employees, but the post-war economic reality remained difficult. In the spring of 1919, 15 tanks passed testing and were formally handed over to the client. Of these, 10 units were deemed ready for service and sent to training units, while the remaining 5 were placed in storage as a source of spare parts and for technical experiments. Engineers continued studying the design to identify solutions suitable for future projects. Particular attention was paid to the twin-engine setup, which theoretically improved the vehicle's survivability if one engine failed. 10 machines were distributed to military bases across the United States. Crews who had experience operating French Renault models noted the specifics of the American design. The lack of a rotating turret was perceived as an outdated technical solution, typical of early British models. Managing 2 independent engines required high skill and constant concentration. Instructors were critical of the design, comparing it unfavorably to its French counterparts. Nevertheless, the personnel began mastering the equipment. Summer exercises revealed operational flaws in conditions approaching actual combat. The limited field of fire created a vulnerability to flank attacks, and vibration made aimed fire impossible while on the move. Technical malfunctions in the suspension and problems synchronizing the engines led to a drop in the unit's combat readiness. Maintenance took up a significant amount of time, often exceeding the length of the training process itself. Actual fuel consumption turned out to be higher than calculated, and the range was lower than stated in the documentation. In the fall, Command made the decision to withdraw these tanks from service and replace them with licensed copies of French models, production of which had been set up in Ohio. The French design had confirmed its effectiveness during the war, whereas Ford's project remained an experimental development that never managed to see action. Engineer reports noted the futility of the twin-engine layout and the fixed weaponry. These conclusions were taken into account when formulating requirements for future American armor. 1920 marked the final stage of full-scale operation for Ford-designed tanks in American Army units. Going forward, these machines were used exclusively for demonstration purposes during military parades and public events. Although the public showed interest in the unusual design, professional military specialists no longer found any practical value in it. A few units were transferred to technical schools, where they served as visual aids for students studying the basics of tank building. One example was displayed at an industrial exhibition in Chicago as a specimen of American engineering thought from the Great War. By 1921, most of the machines had completely broken down due to critical wear on the engines and suspension components. Since spare parts were no longer being produced and existing reserves were exhausted, the War Department deemed it unjustifiable to fund repairs for the obsolete hardware, especially with more modern French-designed machines arriving in the Army. The remaining examples sat for some time in open lots at military bases, corroding under the elements. In 1923, a large-scale rearmament program for tank units began, in which Command decided to standardize the armored fleet based on the proven Renault design. By that time, the factories had established stable production of the licensed copies, designated the Model 1917. These machines were superior to Ford's tanks in every tactical and technical regard. They were equipped with a rotating turret, a single reliable engine, and a proven suspension design. The remaining 3-ton tanks were moved to military storage. By the mid-1920s, the operational history of this model came to a complete end. All 15 produced units were officially decommissioned and removed from Army inventory records. Most of the equipment was scrapped for metal and sent to be melted down. The engines and individual components found use in the civilian sector, while a few hulls were used as targets at artillery ranges where they were eventually destroyed during training exercises. Not a single specimen was saved for museums, as historians of the period saw no value in preserving a machine that had no combat experience. Henry Ford never returned to the idea of manufacturing tanks, focusing entirely on producing automobiles and civilian machinery. The experience of creating an armored vehicle showed that military production requires different approaches than mass automotive manufacturing. The attempt to apply assembly line methods to tank production without considering the specifics of combat application proved to be a failure. The history of the 3-ton tank served as a clear example for future generations of designers, demonstrating the importance of timely development and the necessity of thoroughly testing a concept before beginning series production.